This next video talks about graphing limacons. Okay, so the limason has the equation r is equal to a plus or minus b cosine theta, or r equals a plus or minus b sine theta, where a and b are both positive. Okay, so again, we have four scenarios here, right? And remember that if you have cosine, the graph is symmetric with respect to the 0 pi axis. If you have sine, the graph is symmetric with respect to um, pi over 2, 3 pi over 2 axis with respect to the vertical axis. Now, as I was saying, there are four cases here. We have a limason with an inner loop. So you see this circle inside, that's the inner loop. And you have this graph if you have A is less than B, or if A over B is less than 1. This would be the behavior of the graph. You have an inner loop. Now, this is an example of the equation r equals a minus b sine theta. So notice that it is symmetric with respect to the vertical line, okay? And it is down because it is below the horizontal axis because this is negative. All right, this second example is a cardioid. It looks like a shape of a heart. And this happens if A is equal to B, or if A over B is equal to 1. Now, this is an example of a limason whose equation is A plus B cosine theta. So since it's cosine, it's symmetric with respect to the horizontal axis, and it's on the right side because this is positive. Next, we have a dimpled limason. So a dimpled limason occurs when A is between B and 2B, or if A over B is between 1 and 2. So we don't have an inner loop. This looks like a cardioid as well. However, okay, what we do here is usually this point is not at the origin. So it all depends on the value of A and B. Okay, so this one has an equation A minus B cosine theta. Again, since it's cosine, it would be symmetric with respect to the horizontal axis, and it's on the left side because this is negative. And the last one we call a convex limason. This looks like a circle, okay? And you have a convex limason if A over B is greater than or equal to 2. Okay. This is an example of a convex limason whose equation is A plus B sine theta. Again, it is symmetric with respect to the y-axis, and it is above the horizontal line because you have a plus sign. Let's have several examples. Example number 1. So we are given the equation r equals 3 plus 5 cosine theta. So this limason is symmetric with respect to the horizontal line because it is cosine. And it is on the right side because this is positive. So let's identify our values. Our A is equal to 3 and our B is equal to 5. So A over B is 3 over 5, which is less than 1. So this limason has an inner loop. Okay, it would look something, so we have an inner loop here, and then it would look something like this. Okay, just a sketch of it. Now, what points do we need when we graph a limason? We'll just find 5 points. Okay, 1, 2, 3, 4, no, 6 points. We need 6 points just to graph it. So we know that the maximum is a plus b. So we find a plus b. A plus b is equal to 8. So that means the distance from the pole to that endpoint is equal to 8. That's the maximum. Now, what about the inner loop? The inner loop is b minus a. And b minus a is equal to 5 minus 3 is equal to 2. So that's the distance from the pole to the inner loop. Okay? And then the a represents the intercept, the vertical intercept. Let's call it vertical intercept. It means these points right here. Okay? Okay, so let's see. Let's plot these points. So we have the pole, okay? And then we have the maximum, the 8, that's the a plus b. So 1, 2, 3, 4, 5, 6, 7, 8. And then we have b minus a is equal to 2. That would be the distance from the pole to the inner loop. That's this one, okay? And then your intercepts are at a, which is 3 and negative 3. 1, 2, 3, 1, 2, 3. We don't have to be perfect, but we want to at least know how the limason would look like. Okay, so let's add 2 more points. Now we have here cosine. So we don't want the square root of 3 over 2 or the square root of 2 over 2. If you're given this complete unit circle here with the given what do you call this, angles, then we want cosine theta to be equal to 1/2. Okay, so where is cosine theta equal to 1/2? When theta is equal to pi over 3, right? So plugging this in here, we have r is equal to 3 plus 5 cosine pi over 3. Cosine pi over 3 is 1/2. And this would give us an r value of, that's 2.5, 5.5. So we have this point. R is 5.5 when theta is pi over 3. Okay, again, you can use degrees. It doesn't matter. So let's plot that point. So when theta is pi over 3, your R is 5.5. 1, 2, 3, 4, 5.5 would be somewhere here. And then again, it is symmetric over here. So we have this 5.5. So we have these points. Okay, let's start with the inner loop. Okay, so here is your inner loop. I'm not very particular about the other points here, but you have this inner loop. And then you have the outer loop. Forgive my drawing. Okay, but there you have your limason. Okay, pause the video and try this second one. When you have finished, come back here and we'll continue. Okay. So for this one, your limason is down here, right? So your A is equal to 2, B is equal to 5. Remember, A and B are both positive. A over B is equal to 2 over 5, which is less than 1. That's why you have the inner loop. And this, since this is negative and sign, it will be symmetric with respect to the vertical axis. So we have our A plus B is equal to 7, and then B minus A is equal to 3. That's your inner loop. And then your intercepts are at 2. So let's see, we start here, 7 units down. 3 units for the inner loop. And then, let's see, this is sine, so we'll use sine of pi over 6. Sine pi over 6 is equal to 1 half. So we have, let's calculate. So we have r is equal to 2 minus 5 times 1 half. So that's 2 minus 2.5 is negative zero point 0.5. Am I right? 2 minus point, that's negative zero point 0.5. So we have the point, negative zero point 0.5 and pi over 6. Oh, the intercepts. The intercepts is at 2. So we count 2 units, no, 2 units left and right. So 2 units, 2 units. And then when theta is pi over 6, this is our pi over 6. Zero point 0.5 would be on the other side, somewhere here. Um, and then it will be reflected right over, no, it's zero point 0.5. 0.5 is right here, reflected over here, okay? And then we graph, so we have this inner loop, and then we're gonna have that outer loop. Now again, if you want to do more points, you are welcome to do so. Let's take a look at the next one. So number 6 is r equals 3 plus 3 cosine theta. So note that this is cosine and it's positive. It would open it would be symmetric with respect to the horizontal axis. Now a here is equal to 3, b is equal to 3. So our a over b is equal to 3 over 3, which is equal to 1, which means that this is a cardioid. No loop, cardioid. Um, what else do we need here? Our a plus b is equal to 6. Okay, notice that b minus a is equal to 0, so that's why we don't have that inner loop. Okay, so your intercept is at 3. So it would look something like this, a cardioid. So let's plot the points. Start with the pole, and then the intercept is at 3, 1, 2, 3, 1, 2, 3, and then your a plus b is 6, so 1, 2, 3, 4, 5, 6. So these are your 4 points. We need 2 more. Again, since this is cosine, we'll use pi over 3, because cosine pi over 3 is equal to 1 half. So r is equal to 3 plus 3. Let me write it down. Cosine pi over 3. So that would be r equals 3 plus 3 times 1 half. And this would be equal to 3 times 1 half is 1.5 plus 3. So r is equal to 4.5. So we have the point 4.5 pi over 3. So pi over 3 is right here, 4.5, 1, 2, 3, 4.5. And it's reflected over here. Okay? So your cardioid would look like this. Okay, again, pause the video and try number 7, and then come back here. So for number 7, A again is equal to 4 and B is equal to 4. They are equal, so you have a cardioid. 4 over 4 will give you 1. So you have a cardioid here. Cardioid. Okay, A plus B is equal to 4 plus 4, which is 8. And then if you do find the r, so this is sine, we'll use pi over 6 for sine. So we have r equals 4 minus 4 sine pi over 6. Sine pi over 6 is equal to 1 half. So that would be 4 minus 2. R would be equal to 2. So we have the point 2 pi over 6. Okay, and this is sine negative. So you know that your cardioid would be opening down. Okay, so let's plot these points. We have the pole, and then 8 units down, and then your intercepts are at 4, so we count 4 left and right. 1 2 3 4, 1 2 3 4, and we have the point 2 pi over 6. This is our pi over 6. It's equal to 2, and it's reflected over the other side right here. So we have got this cardioid. Oopsie. Okay. All right, next one. We have 3 minus 2 cosine theta. So our A here is equal to 3. Our B is equal to 2. 3 divided by 2, that's equal to 1.5. Okay, which is between 1 and 2. So this one is a dimpled limason. So again, we need our A plus B, just like we were doing. It's equal to 5. B minus A, that's equal to 2 minus 3. And that would be equal to negative 1. Okay? That's why we don't have an inner loop, because this is negative. What else do we need? Okay, so since this is cosine, we will use pi over 3. To find r, we get 3 minus 2 cosine pi over 3. Cosine pi over 3 is 1/2. So we get 3 minus 2 times 1/2. That's 3 minus 1. So our r is equal to 2. So we have the point r is 2 and pi over 3. So let's plot these points right now. Starting with the vertex, it's a different color here. Starting no with the pole, okay. Oh, by the way, your cardioid or dimpled, yeah, dimpled limason would look like this. So this is cosine and it's negative, so it would be on the somewhere something like this, okay, right side. So we have the intercepts. Let's do a plus b first. It's equal to 5. So we count 5 units. 1, 2, 3, 4, 5. And then your b minus a is negative 1. So we'll count it onto the other side. So this one is your b minus a. And then your intercepts are at a, which is 3. So 1, 2, 3. 3 up. 1, 2, 3. 3 down. And then we have another point here when theta is pi over 3. Pi over 3 is right here. Your radius, your r is equal to 2. 2 would be right here. Oh, we don't have the point 0, 0. I'm messing up. We don't have this. Okay, we don't start with the pole. Oops. Okay. And then this point will be reflected over onto here. Okay. So we connect these points and you have your dimpled limason. So there's that small dimple right here. Okay, again, stop the video and try the next one. So for number 9, A is equal to 5, B is equal to 4, A over B is equal to 5 over 4, which is between, it's 1.25. That's between 1 and 2. So you have a dimpled limason right here. Your A plus B is equal to 9, and A minus B is equal to negative 1. And then since this is sine, we use pi over 6. So r would be equal to 5 plus 4 sine pi over 6. Sine pi over 6 is equal to 1/2. So this would be equal to 5 plus 2. R is equal to 7. So you have the point 7 and pi over 6. Okay. So A plus B. So you know that your limason, it's positive sign, so it would be to the right, to up. Okay, so we have A plus B is equal to 9. Okay, I'll just add in that 1 point because this is only up to A. And then A minus B is equal to -1, so -1 on the other side. And then your intercepts are at A, so 5 units, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then your other point is pi over 6, 7. Here is pi over 6, here is 7. It's reflected over on the right side. And then you connect, and you would have this dimpled limison. All right, we have got two more examples here. So number 10, we have r equals 4 minus 2 cosine theta. So we have A is equal to 4, B is equal to 2, A over B is 4 over 2, which is 2, exactly equal to 2. So this one is convex limison. All right, so again, A plus B, that's equal to 4 plus 2 is 6. And B minus A is equal to 2 minus 4, which is -2. Okay, this is cosine, so we'll use pi over 3. We have r equals 4 minus 2 cosine pi over 3. Cosine pi over 3 is 1/2. So this is going to be 4 minus 1 is equal to 3. So we have the point 3 pi over 3. Um, so we have our maximum is at, by the way, this is cosine negative. So it would be on the left, right? So we start with A plus B is 6. So we count over to the left. 1, 2, 3, 4, 5, 6. And then B minus A is -2. So 2 units right. 2 units on the other side. 1, 2. And then your intercept is at A. So 4 units. 1, 2, 3, 4. 4 units done as well. 1, 2, 3, 4. And then we have this other point. 3 pi over 3. So pi over 3 is right here, and then we count 3, 1, 2, 3, and then it's reflected over onto the other side. So when you connect these points, you would have, so the convex looks like a circle. Sometimes it even looks like a dimpled limison, but yeah, there is a subtle difference. Okay, go ahead and again pause your video and go for number 11, the last one. So in here, A is equal to 5, B is equal to 2. So A over B, that's equal to 5 over 2, is greater than 2. So this would be a convex limison. A plus B, that's equal to 5 plus 2, is equal to 7. And B minus A, that's 2 minus 5, it's equal to -3. And then since this is sine, we'll use pi over 6. So we have r equals 5 plus 2 sine pi over 6. So we get 5 plus 2 sine pi over 6 is 1/2. So 5 plus 1/2, it's equal to 6. So we have the point 6 pi over 6. Okay, so let's plot this. Let's start with A plus B. A plus B is, oh, by the way, your limison, since this is sine and it's positive, it would be above. Sorry, it would be above. Okay, so your A plus B is above. It's equal to 7. A minus B, it's negative, so it would be 3 units on the other direction. Intercept is at A, which is 5. So we count 5 units, 1, 2, 3, 4, 5. 5 units right. 1, 2, 3, 4, 5, 5 units left. And then we have the point 6 pi over 6. Pi over 6 is right here. Okay, so this is our pi over 6, and it's equal to 6. And then it's reflected over onto the other side. So we have got this. Again, if you want to be more accurate and plot more points, you are welcome to do so, but it's not necessary.